After previous class, what we have learned about the solid state, we are now going to proceed about the packing fraction. Packing fraction means in solid structure, in basically the packing, how the crystal is packed, that efficiency, that atom with a void, with a total geometry of the structure, there is a certain fraction, means the total volume and the space occupied by those atoms in that crystal. In solid state, if you have the knowledge of packing fraction, then you can have the idea about the crystal structure. Now, what is packing fraction? It is basically formulated as volume of atom divided by volume of total. That means the percent of volume acquired by these atoms in a solid crystal. This is basically packing fraction, and basically it must be multiplied by 100 as it is a percentile. So now start with a simple cubic system, that is a SCC, simple cubic crystal, in which you can see a simple cube, the atoms. There are 8 atoms, and the atoms, if I can consider the atom as spherical things, when we are assume that spherical thing atom is spherical, then we can conclude that the volume of the atom should be 4/3 pi r cube. Then the volume of atom is now placed 4/3 pi r cube, where r is the radius of that atom, because we are assuming that atom is spherical. Now the total volume, what? Total volume is the volume of cube, and you've learned already in class below class 10th or in substandard of class 8 or 9, the volume of any cube is the cube of one arm, that is A. Here A cube is the volume of cube, that is the volume total. So the packing fraction literally leads to 4/3 pi r cube by a cube into 100. So now we need to know that what is r here, because here you can see that the two atom is occupied in a arm. So the arm is shared by two atoms. So A is basically twice r. Now we can calculate, we can cancel out those r, and we are getting the packing fraction is this value, like 52.4% approximately. So we can also calculate this packing fraction for other crystals.